Okay, let's start with the serial data set. So we load it up, and again, we import pandas, we import NumPy. We set this option so that it will display all the columns, because if I don't set this, if when I look at the data set, if it's wider than the notebook, it's just going to exclude some columns and won't show them all. So we want to be able to see them, which means that we'll have to scroll left and right to see them all. And then we import plotly.express as px. And again, the reason we have these as px, as mp, as pd is so that when we refer to them, we don't have to write out the entire plotly.express. We can just write px, or instead of writing out pandas, we can write just pd. So we load the data frame, and again, we gave it a URL of a CSV file, which is just the most basic kind of table of values. And so we put that URL into a variable called URL, and then we created a data frame by using pd.read_csv, and then the the URL that contains the URL for our data set. Okay, so when we look at this thing, we look at the columns, we can see that there are a total of 18 columns. We have 4 that are objects, and these are going to be text columns: name, manufacturer, a manufacturer code, and whether it's hot or cold. And then we have a series of quantitative measures of the cereals. We have calories, protein, etc. So we have a total of 13 or 14 of those, or I'm sorry, 13 of those, and those are all either integers or floats. And then we have this fiber gram, which is it's a categorical variable, because what it says is what category of fiber does that particular cereal fall into. So here we can see we have the name of the cereal, the manufacturer, and the manufacturer code, hot and cold, so that's just H or C. And then we have a bunch of quantitative variables, and then we have this fiber grade, which is either low, medium, or high. And for the most part, we have all the data for each of the 76 cereals, except we have no weight per serving for this one cereal here, which you can see we end up with this NAN, which is the indicative of the fact that we're missing a value there. Okay, so we've listed out the categorical variables, and then we want to use df.column name to figure out the manufacturers. We're going to use our value counts. So what we're doing here is we're saying, okay, looking at just the column manufacturer, what are the different values and how many of each of those do we have in here? And so when we run that, we can see that we get, oops, I did not run this stuff up here. Got that. Okay, so then when we run this, we get that we have 6 different manufacturers of the cereals, the 2 big ones, General Mills and Kellogg's, and then fewer offerings from General Oats and Post, a little bit from Nabisco, and then from American Home. Okay, so the top 2 manufacturers in terms of the number of cereals they produce are clearly General Mills and Kellogg's. Then we want to find the 5-number summary for the amount of fat per serving. And so in order to do that, we're going to put in another code cell here, and we're just going to, first of all, look at the column name, which is fat, and we're going to do df, and we could get all the measures for all of the columns if we just use df instead of df fat, but we only wanted for df fat, so we're going to use df fat describe, and that's going to give us all of these values that are of interest to us. It tells us there are 76 values. The mean value is 1.44 grams per serving. The standard deviation is 1.55. So what that means is that there's a lot of variation. If you look at the standard deviation, the average distance of each value from the mean is actually greater than the mean itself. So we're going to clearly get quite a range in terms of these values. You can see the minimum is 0. The 25th percentile is 0.5. The median is 1. 75th percentile is 2. And the maximum is all the way up to 9. So we clearly have a lot of values between the 75th percentile and the maximum. Okay, so then we want to create a box plot. And we want to take a look at so we're going to create a new column here. And we're going to do px dot box, and that means we're going to be creating a box plot using the Plotly Express, and we want it for the fat level. So we're going to we have to put in the name of the data frame, and then along our x-axis we want to have fat. And then we also want to say width equals 600 and height equals 400. And so when we run that, we get a box plot. And what we can see here is that, again, most of our values here, or half of our values, are between this first quartile of 0.5 and the third quartile of 2. So that's 50% of our values. 25% of our values are from 0.5 down to 0, and then another 25% of our values are greater than the third quartile of 2, including a couple of outliers here, a cereal that has 6 grams of fat per serving and a cereal that has 9 grams of fat per serving. Okay, so then we want to know what are the 5 top cereals in terms of the amount of fiber per serving. And so we can use our n largest for that. So we can say df, and what we want is our fiber. And so going back to look at the column name, by the way, the columns all show up here when as soon as I put this df and then open this, it's going to list out all the the variable or column names here. And again, I'm looking for fiber. So I'm going to choose that, and I'm going to do dot. Actually, no, this is not right. Well, there's a couple ways I could do this. I could do value, or I could do sort values. And when I run that, I'm going to get them sorted, but it's going to go from lowest to highest, and I don't get the actual name. All I get is this column here. So what's actually going to end up being easier is if I use pd.nLargest, and I'm going to tell it that I want the 5 largest, and nope, wrong again, df, and then .n largest. Sorry about this. And then here I want the number of how many values I want, and then the column that I want. And in this case, what we wanted was the amount of fiber. Okay. So now that lists in order of the amount of fiber. So we have 13, 13, 10, 8, and 8 is our top values here. And not surprisingly, some of them have that in the name. Okay, so then you have to find out the top 5 cereals based on the amount of sugar per serving. And so all you'd have to do here is instead of fiber, you would just have sugar. And that's going to run the same thing, except that sugar's not the name. Sugars. And that does the same thing for us, but now it's the sugar. And so we can see that we have 20 grams, 18, 18, 17. And so whatever you may think of these cereals, they actually have a lot of sugar compared to other cereals. The names don't necessarily reveal that because that's not a selling point. Okay, so then we want to create a group by object based on the name of the manufacturer. And so what we're going to do is we're going to create this group by. So we'll call it group 1 equals df dot group by. And we want to just now put in the name of what we want to categorize this by, and that is the manufacturer. And the reason that we're doing this, because we want to look at each of the 6 manufacturers as a whole in terms of some of the values of some of the serial measures. So we want to find the most and the least fiber per serving. And so now that we've created this group, what we can do is we can say group 1, and we're going to just call the column that we're interested in, which we said again was fiber. And we're just interested in the mean amount of fiber, because that's what we want to know, is what cereal manufacturer on average has the cereals with the most and the least amount. So you can see that Nabisco has the highest amount of fiber on average, and General Mills has the lowest at 2.4. So then we want to find out what about the most and the least sugar. And so just as we did above, all we have to do is replace fiber here with sugar and run this again. Except again, it's still sugars. And we can see that Post has the most and Nabisco has the least, and there's actually a fair amount of spread here. Okay, so now we want to create a new group, and we'll call this group 2, except we want to group by, in this case, the fiber GR, which is a categorical variable with 3 different values. And so we create that group, and then we want to look at the average fiber for each of these. And hopefully it should make sense, because the group that's listed as low fiber should have on average a lot less fiber than the cereals that are listed on the mean. So we could look at this now and do group 2 dot, in the square bracket. Now we want to look at fiber. And again, we want to look at mean. We could have chosen something. We could have chosen median, for example, and that would have given us something similar. So here we can see that for the low, it's 0.6 grams per serving. For medium, it's 3.8. And for high, it's 8.3. So the differences are pretty significant, and that's not altogether surprising. Okay, so then we wanted to come up with a question where you want to explore the data, and you want to use a group by, and then take a look at, whatever it is. And I gave you an example. And so, this is something that you'll sort of pick for yourself. And basically the idea is that you want to explore the relationship. Let's say you want to look at maybe the average amount of sugar per manufacturer or something like that. And then you also want to try to use a filter, which is to say you want to use something like, let's just look, here would be an example. DF, and we'll say DF sugars, and we'll say greater than 10. Okay, and so we get all of these that have sugar greater than 10 grams per serving. There's a fair amount of them. Let's push it up to 15. And now we can see we get the ones that are 15. You might do something like looking at creating a group by, where you look at, you use the hot cold category to create the 2 different categories, cold and hot cereal, and look at calories per serving or something like that. So those are the sorts of things that you can do, and then write it up in 3 or 4 sentences.